We used to talk about diesel, now we're talking about electric. 40 cars in one bucket, that is crazy.
.3,400 horsepower, which is equivalent to 2 Bugatti Chiron.
Hi, I'm Peter Haddock and I'm here at Bauma for the very big moment. Backhoe excavator here, slightly larger than we normally see on the job site. This is the PC7000 and it is electric as well, isn't it, tethered?
That's correct.
Thomas joins me here. Tell me about a few of the stats of this beast at Bauma.
So you see in the background this PC7000 beauty. It's a 700-ton excavator.
Yep.
We are introducing here at Bauma our new configuration with the 44 cubic meter bucket. So what I like to tell about this bucket, basically you are lifting 80 tons of material with one scoop. So we are talking about roughly 40 mid-sized cars that you can lift with one bucket.
40 cars in one bucket, that is crazy. And of course you need some very big trucks that it can fill as well. You've got one of your trucks next to it, haven't you? So this application's obviously very restricted generally. So we're talking about big mines for this kind of machine, aren't you? But the configuration, why would somebody choose this configuration against a front shovel, for example?
So it really depends obviously on the mining application that you have on site. So depending on, let's say, the circumstances that you have on site, the mine planning that you do, it will then depend if you rather go for the backhoe or the front shovel configuration. Yeah. Also, let's say the working condition, if you want to rather move backwards or frontwards, will determine whether you go for a backhoe or a face shovel configuration.
So you bring it to Bauma, but it's a big machine. How many trucks does it need to bring this to Bauma? And I guess it takes weeks to put together.
So in the end, it's more than a dozen of trailers that you require to bring all the single parts on. It's a bit like Lego, you know? You bring all the parts here and it takes you about 4.5 weeks due to the special circumstances that we have on site to assemble this beauty.
And then, of course, when we talk about big things, we used to talk about diesel. Now we're talking about electric. That's a big difference, isn't it, when it comes to sustainability, but also when it comes to the requirement of power going into the job site. So electric is now becoming much bigger in mining, isn't it?
It is really, and that's the reason why we brought the electric machine in here. In the market, many think that backhoe and electric as a configuration do not work together. One thing you mentioned, it's completely different, yet the same, because in the end, the power and productivity that you get out of an electric machine is the same compared to its diesel counterpart. So we have both on this electric as well as on the diesel counterpart, the same rated power, 3,400 kilowatts. So you get the same productivity out of an electric machine than you would get on a diesel one.
And of course, it's just their diesel has engines, these have electric motors, and they must be huge, these things.
They are, and I will show you soon how they are.
So come here and let's discover how this works and also some of the key critical features for the electrification. So tell me a little bit about it as we walk and talk, folks. So electric, how do you manage that on the job site?
So usually you have a substation close to the machines, which is connected to the mine grid. And then you have a trailing cable, you will see it soon as we approach it, that is then connected to a cable drum on our machine. It's a bit like a large vacuum cleaner back home, but just a few sizes bigger. So what does that mean? You have a cable drum in the back, you have the trailing cable, like I said, connected to a substation. And then depending on the voltage that you have on the machine and the diameter of the trailing cable that you have roughly 200 to 300 meters of operating radius around your substation, giving you enough mobility and flexibility to do the job with an electric machine.
Fantastic, and that's the way, that's then about management of the job site, isn't it?
Exactly.
And management of the electric coming into the job site.
What's also very important to say, I mean, the cable drum is all automatic, so there's no requirement in the cabin that the operator operates it. So depending on the tension that you have on the cable, it will automatically wind up or down. So giving you really kind of space and freedom to concentrate on the operation of the machine rather than on the cable management.
Yeah, and again, anything that's automated in a process like that is really, really exciting. So, folks, these are the tracks. Let's have a. I mean, come on, this is absolutely massive. So, what are we talking about with the track side?
So, I mean, you see several track pads.
Yeah.
Each track pad weighs approximately 800 kilogram. So you can easily imagine what weight we have on this machine. It's just tremendous.
That's tremendous. What is the overall weight of one of these machines then?
Well, let's count. I think it's more than 40 tracks that track pads that we have in one track.
Wow.
So it's very easy to calculate what kind of tonnage you in the end have. I very much like it. We are producing these machines back in Germany in our factory in Düsseldorf.
Yeah.
We're not only doing the assembly, but actually doing also the manufacturing of the whole undercarriage.
Okay.
So when all this more than a dozen trailers are leaving, mostly you have big and large parts, but then you have also 4 of the small trailers that are just carrying these track pads. It's just tremendous
Wow,
to
that's
see.
tremendous, isn't it? Fantastic.
It is.
So, tracking, we've done that. Electric, we've done that. Now we need to go up where actually it all happens, don't we? Come on.
Follow my lead. One particular thing that we are very proud of now, walking up the stairs, you notice that we do a lot in terms of safety.
Yeah.
So the access ladder, which we are right now stepping on, is having a 45 degree, which means it's quite easy and convenient and ergonomic to climb it up.
And then that basically moves up.
Correct.
When it's in configuration. So you got a fun fact for me now that we've got up to level 1, I guess, here. Tell me about it.
So we will go into the machinery house. You will see the electric motors. And fun fact is actually we have a combined power of 3,400 horsepower, which is equivalent to 2 Bugatti Chiron. However, this machine obviously does not run 400 kilometers per hour, but just 2.5, which is no problem. I mean, we need the rated power basically to really dig and penetrate the material, right?
Fantastic. So when we talk about engine room, we're actually talking about motor room now, though, aren't we? So come on, let's go and have a look at the motor room. So normally you would have had a diesel engine in here. I think it's probably a little bit more spacious now with 2 electric motors, isn't it?
It definitely is. So usually when you are having here the diesel configuration, it's much more narrow. But that's also the beauty of the electric drive, right?
Yeah.
You have quite small-sized motors, which give you also a lot of flexibility to move around the machinery house.
And when you're talking about electric, you know, we're talking about small electric machines and we're putting power into them. We're talking about AC and DC and things like that. Are you just getting a direct supply in the right format in the DC or AC? What would it be?
You usually get that. That means the substation is already configured in a way that you get exactly the energy, the voltage, the frequency that you require. A fun fact that is also showing the flexibility of these electric motors is in Germany, the main grid is 50 hertz.
Okay.
Here, these engines are running with motors are running with 60 hertz.
Right.
That means we have a frequency converter outside. We have 2 transformators that give us on the one hand side the right frequency as well as the right voltage. It's here 6.3 kilovolt that you have on this machine.
Right, so there is a little bit of engineering that needs to be done, but then no power loss. Because when you're doing the transformation in a transformer on the substation, that's the best and most efficient way of doing it, instead of putting inverters everywhere in the machine. So that comes directly. That's really interesting. Again, an infrastructure piece, isn't it? Yeah. So this looks like pretty spacious. What else have we got behind us here? The hydraulics?
That's the hydraulics, exactly. So the motors are basically converting your electric energy into the power that will then power our hydraulics. So you have 3 main pumps behind each of the motors, which are then delivering a flow of approximately 1,000 liters per pump per minute.
Wow. That is a huge amount of hydraulic power. Well, you've got to do that for that lifting of the 80 houses I think we talked about earlier, hasn't it? Fantastic. Right, where to next? We've got the power. Then where do we go?
The question is, to which consumer do we send the power? So let's move outside to the valve blocks.
Fantastic. Danger, folks. High voltage here. Oh my goodness me, what have we got here? So this is where there's an awful lot of hydraulic hoses that are rather larger than the ones you would see elsewhere, aren't they? So that 1,000 litres per pump coming into this here.
Exactly, exactly. And then you have your control blocks, which then define based on the controller position inside the cabin, to which hydraulic cylinder, to which slew track, or to which drive this whole hydraulic power will go. So it's a quite smart system. That means not one pump is just feeding one consumer, but depending on the demand, you really push either everything to the bucket and the stick, or to the boom, or to the slew circuit, right? So really based on this, let's say, smart system, we then determine where the power is required and deliver the flow to the respective consumer.
And that's all about controls, folks. So wow, there's a lot of power going into this. So where to next?
I would say the cabin, huh?
Let's go into the cab.
Where
Turn it on and get moving. So we got to go
upstairs,
up the stairs. So we were going to go first into the cab, but the music's playing. I think we should go to the dance floor. Come on, let's go. So folks, the dance floor is where we're going now. Normally, this dance floor wouldn't exist. Now, why has this dance floor become a cool part of the machine? Surely there was something here before.
Exactly. I mean, we are talking about an electric drive. That means you don't need an air intake for your turbochargers. You don't need an exhaust system. And that's basically the reason why we are having here a quite spacious environment to engage after the show or after the shift, right?
Get out our picnic blanket and do that.
All possible.
That's the thing that you don't recognize with these sort of things. But now you're talking about that. That's just fewer components. So you've got smaller motors, fewer components because they're not here. So therefore, you must have taken quite a lot of weight out of this machine then when you're doing an electric. And that's going to help productivity and the movement of the energy needed to do that.
That's correct, that's correct. And I mean, one thing that should not be underestimated, on the one hand side, obviously you have obvious savings in terms of carbon footprint reduction when you go electric. But like you said, you have smaller components, you have less complicated components, you need less lubrication, you need less service labor also to maintain these components. So also from a total cost of ownership perspective, it's way cheaper operating these machines in electric rather than diesel. The only circumstance that you need to overcome is bringing electricity on site. That's the key point.
But if you've got things like a hydroelectric station and you're getting green energy coming into that as well, that makes a difference. But again, not moving as much material as in the machine itself, and then concentrating on that shovel, and that's brilliant. So was there any need then to add more weight to the machine anyway, though? Because when we talk about counterweights, all of these things have been designed with all that weight in mind, isn't it?
You just said it. It's really the counterweight that is then also different, which you need to keep into consideration, that you somehow need also to counterweight the power that you have. But however, it's not that big of a difference, to be honest, in this case.
So now it's time to go inside the machine and actually see the view, which is slightly different from mine because it's Bauma, folks. Come on, let's have a look. So come and join me in probably the biggest cab for an excavator you're ever going to see. Look at that visibility out there. We've got the standard things like touchscreen controls, obviously joystick controls, and some very, very large. I'm just thinking, do I really put my feet on these? But obviously it's not on, folks. So here, this is the station that matters, isn't it?
Exactly. That's where all the magic basically happens, right? So I think every one of us, being a boy with 5-6 years old, once at least dreamt to operate one of these things, right? At least for the smaller ones. You could probably even not imagine that these big ones exist at that time, right? So for most of us working with Komatsu, it's like a dream coming true, right?
Absolutely. And I think, you look at this here, you're obviously in a mine environment, so there aren't people around and things like that. But you're in this zone, there's lots of lighting. Again, we're going to be working around the clock sometimes in mines as well, aren't we? So we've really got to concentrate on operator comfort and actually keeping that operator safe in the cab as well, haven't we?
Exactly. I mean, in the end, we do a lot because it matters that the operator feels comfortable. The moment he feels comfortable, the more productivity you also get from that. So we have different features that support it. On the one hand side, obviously there's an air condition in, there's a heater.
Yeah.
So we have these machines working in the, let's say, most severe circumstances. Sometimes in areas where we have -40, -50 degrees Celsius.
Wow.
In the Nordic, in Europe, or the most northern parts of Canada. Then we have them working in the outback in Australia, or somewhere in Africa where you reach +40, +50 degrees sometimes Celsius.
Wow, yeah.
So also that's very important. Then you have a pressurized cab. Sometimes you have very dusty mining environments, so you don't want to get any dust or dirt inside the cabin, right? And then it comes to very simple features like having a radio system, like having a fridge for the beer for after the shift. So it's all in here.
Absolutely. And then when it comes to operators, we see a lot of things now being talked about at the show, operator assist functions and stuff like that. Is there a similar sort of thing, the technology that helps fill that bucket? Because every time you go in to fill that bucket, that's an awful lot of houses that you're putting in there.
That's
but
correct.
if you're not filling the bucket right each time, it's a big cost that's coming there, for because the cost per tonne per litre is significant, or in this case, per kilowatt, folks, is significant, isn't it?
It is. It actually is, and that's the reason why we also have a payload meter system and an operator assistant called August, which determines on the one hand side information. Usually you have also a screen here available as an option, which you can choose from, that you get on the one hand side the information from mine planning. Obviously, you don't have heterogeneous material, so you really want to know, is it now waste rock that I'm digging? Is it rich material? So this gives you the guidance, and also gives you the guidance basically that you dig in a way that you can optimize also the haulage and know to which crusher to go, as well as safety features. I mean, on the right-hand side, when the machine is running, you have our ComVision system, which is a 360 degrees bird's eye view, which helps you to basically understand the surrounding around the machine. We have 6 cameras all over the machine that you can either see from the top, really from a bird's eye view perspective, like you know from the cars and the automotive industry, as well as selecting individual cameras to really know what's happening, for instance, behind you or on the side of the machine.
Fantastic. So you've got all the guidance, you've got all the support, and we've certainly had a great guide here today. Great to see you. Cheers.
Peter, it was a pleasure having you guys.
Thank you.